All right. Okay. So I'm gonna the review final exams for chapter 5 and 6. Again, more focus on the question. Okay. I'm gonna very quickly go over because there is a lot of the huge range of the chapter 5 and 6. I'm gonna very quickly go over 20 or 30 minutes for you know the based on the questions and also concept as well. And also chapter 5 end of session, and also we're gonna the part 2 for the chapter 6. Okay. All right. So for chapter 5, we have already discussed before synchronous sequential logic. So we learned before the concept compared to the combinational logic as well. Okay. So we are in here, I mean, for the final exam, this cover for chapter 5 and 6. Okay. Right. So this is the homework questions and quiz. Hopefully you review again. All right. So this is the outline, the concepts, sequential circuit compared to combinational circuit. And then we're gonna learn about asynchronous or synchronous sequential circuit. We have two different types of storage element. One is the latch, the other one flip-flop. Just the main difference is the clock. Okay, clock. So the latch, we're gonna learn about two type, SL and D. We learned before. You have to study, and also flip-flop. We're gonna learn about SR, D, JK, and T. Okay. All right. And we also try to analysis of the clock sequential circuit, a lot of the application, as well as we learn about state reduction and assignment. Okay. All right. So again, you have to study here. So again, combinational circuit only consider about present inputs, okay, and the output after passing combinational circuit, which includes a lot of combined logic diagrams. But sequential circuit, they have two memory elements. The one of the output is also effect to the future output with the input as well. Okay. So, um, the sequence circuit has the two type, as I said before. One is asynchronous, the other one synchronous. Okay. Sequence circuit. So asynchronous circuit, sequential circuit, do not rely on the clock signal. It's very important. Okay. State can change at any time in response to the input change. Okay. And then there is the no clock signal. Okay, no clock signal. So means the input change anytime and also directly cause state change. Um, so for this case, a synchronous sequential circuit is to memory element latch. Latch is immediately respond the input. That is the one of the benefit. However, uh, it's kind of require more complex timing analysis due to make it like propagation delay that we learned before. All right, this is the synchronous sequence circuit. That is for the clock pulse as well. The input here rely on the clock signal. This is the most important for flip-flop. The state change. State change can occur at the rising or falling edge. Okay? Rising or falling. This is the rising edge. The PGT is the NGT. Okay, 120, 021. So if you wanted to explain about a synchronous sequence circuit, you have to mention the clock signal, PGT or NGT. Okay. So they have the three difference, but especially the rising and falling edge, PE, the positive edge response, negative edge response we learned before, and also this much symbol as well. And then this is the compare, okay? More faster, it's comparatively slower than the ledge with the large gate, more complex. That is also clock the large gate. Require clock signal for the operation flip-flop, but the ledge do not require clock signal for the operation. All right, so that is for the storage element is NOR gate. Okay, we're gonna learn about if we wanted to learn about SLH with a NOR gate, just so if the input is one, output is going to zero. Okay, learned before, gonna more faster. So the SLH with a NOR gate, so reset and set. So some student ask me, Professor, can I have much change here? Yes, you can change, but the same output. Okay. So that is for right there. Here we go. This is the SLH with a NOR gate. So 0, 0, no change. 1, 0, 1, set 0, 0, 1, 1, the in-belly. Okay. I strongly recommend you have to memorize. It's very important. Definitely I'll try to the upload I have attached to the in the last page of the final exam. All right, so that is the is set and reset. It depends on the random value. We can expect it to cue the output. It depends on the T sub one in here because it depends on the value S and R, and this is set. This is the R set. 0, 0, 1, 0, 0, 1, 1, 1. So it depends 0, 1, 1, 1, 0, 0. Okay, you have to practice all of them. So in our class, we learn about two different type SLH. One is SLH with a NOR gate. The other one is SLH with a NAND gate. Okay, so very important. So you have to memorize. Okay, you have to memorize and to understand and practice as well. So we learned before it depends on the SLH with a NAND gate. So it depends on the SLH with a NAND gate or NOR gate. They have different, is the value. Okay. With a NAND gate, that was the 1, 0, 0, 0, 1, 1, 0, 0. So the invalid. Okay. All right. So in here, storage element SLH with a control the inputs. This is the one of the questions in the what's example. So please be careful because this is the SLH with a NOT gate. So the set or reset value. So they have not changed in Q value. Okay. So 0xx no change and 100 no change. 101 Q is equal to 0 reset. 110 Q is equal to 1. 111 and indeterminate. Okay. And then this is all this is the more DREG. But DREG is like the transparent 0, 0, just like the rates don't change, but the 1, 1, the only change Q value is like same as the input of the D. Okay. So that is what you have to do. Very important. That might be one of the possible questions. The circuit, I gave you the table. All right, so that is for what? This is also very important storage element, the DREG. This is the another type here. Oh, no, it's like the same type. Yes, same type. So D is the input that carries the data to be stored. The E is enable the control signal, determine when the latch should the capture and storing the data. That is what you have to do. All right. So again, so if you want to just try to, it depends on the value, for example, 0, 0, 1, and also 0 or 1. They have a different value. It depends on the, different value. SLH with a two non-gate, you can expect to the value, okay? I strongly recommend you have to practice as well. All right. So now we very quickly go over storage elements in the ledge as R and D. Now we're going to learn about storage elements for flip-flops. Flip-flops. There's a lot of type, but in this here, we're going to learn about S, R, D, J, K, and T. Okay. All right. So storage elements, flip-flops. What is a flip-flops? A flip-flop is a small digital memory devices. It store one bits of data, zero or one. Think of it as on and off switch that remembers its last position. Okay, so flip-flop are the basic building of the digital circuit. So again, it's very important. Just flip-flop the change state. Okay, state mean include the time concept. Okay, this is the sequence circuit, not the combinational circuit. Okay. So the sequence circuit, we needed to previous value, current value, and future value, right? So in the flip-flop symbol, they needed to the clock, okay? So very be careful. They only to, for this circuit, I mean, this symbol, from the symbol, we figure out just only the PGT they wanted to work in, all right? So 0, 0, no change, and then 1, 0, 1, 0, 1, 0, and 1, 1, the ambiguous, okay? So I will make a more the modify, but um so you have to know, okay? So the PGTK is the only working in the here. So 0, 0, no change. 1, 0, set. 0, 1, reset. 1, 0, set. 1, 0, set. You know, just so this is what it depends on value. Keep going to the here in the time domain. Same thing. Okay. So this is the negative going the transition. Okay. I might be have to plan a little bit in an advanced modified question for this one. Okay. So the PGT and GT from the symbol, you have to figure out what's going on. And also you have to know the input and output right there. All right. So in here, blah, blah, here. So clock or deeply plop. Again, the deeply plop, same as the output. Okay. All right. So this is the storage system. So sometimes it takes a lot of being confused. So maybe I wanted to double check in here. So the truth table is the input and next state. Okay, for the case of the deeply plot. But the characteristic, the table of the deeply plot, they have the clock, the inputs, and then Q of T, the current value. So the input Q of T 0, 0, 0, 1, 1, 0, 1, 1, and the outputs, it depends on the value, but in the deeply plot, same as the input, right? 1, 1, 1, 1. Why? Because from the truth table or sometimes character table. It was kind of sometimes it depends on the books here. And then this is the characteristic, the equation from the K-map. So this is the Q of T, D in here, there. Oops. From here, just only two Ks. So right there, 1, 0, 1, 0. I'm sorry, 1, 0. What is it? 1, 1, 1, 1. So that was the groupings, and D is the characteristic equation for Q of T plus 1. Okay. All right. Now, storage elements. Okay. The positive edge trigger. This is the another type to be make for which is to satisfy the condition to make a circuit. There is a lot of circuit we can make it. Okay, so this is the negative edge trigger deeply plug. We're gonna learn about the master and slave. It depends on we're gonna working the two times. Okay. So please don't learn about. So this is the JK flip-flop, very important. Okay, so the JK, the input control state of the flip-flop in the same way as the S and R inputs to for the clock, the SR flip-flop except the one major. Okay, so the SR flip-flop Gotta write it. SR flip-flop. That was for the ambiguous, sometimes invalid. But the JK flip-flop, that was the toggle. 0, 0, no change. 1, 0, set. 0, 1, 0, 1, 1 is toggle. So we can use the four different options in here, but should be the PGT. Okay, here. All right. So you have to practice. Okay, you have to practice in here. All right. So the JK flip-flop that triggers on the on negative going transition right there. Um, let's say the Q sub zero, no change. Same thing, but just the clock is NGT, the JK flip-flop was working. All right. So the characteristic table, this one PGT, that's definitely J, K, Q of T, the current state. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, right there. So the next state, it depends on the combination. 0, 0, no change. 0, 0, no change. 0, 1, reset. 0, 1, reset. 0, 0. It doesn't matter from the current state. For the next stage, just only effect from the input of the JK flip-flop. Okay? And also sometimes the complement toggle same meaning. So 1, 1 mean 1, 0, 0, 1, just one toggle we learned before, okay? So and then also we're gonna find we can find the characteristic equation by using Kmat. This is Q over T and JK. 1, 2, 3, 4 is corresponding to here. The JK 0, 0, 1, 0, 0, 1. It's one here, one here, one here, one here. Okay. So, and then you want to adjust the grouping and then you can find it, especially that was with JK flip-flop. All right. Same thing. So in here, we're gonna just reduce to the state table for the excitation table, okay? Just only Q over T and Q over T plus one and JK, they can be 0 or 1. Okay. So we can reduce. We have practiced a lot of time. All right, so you can try. All right. So but that is very important. You have to understand. Okay. For the future, a lot of questions, maybe for the final exam, the based on the circuit, the characteristic equations, you have to draw. Okay, you have to draw a circuit diagram. So you have to know the JK, deeply plot, whatever. You have to practice. Okay. And also, the T plot, we can make it by using the JK plot. Okay. So the T plot will be for 0, 2. When T is equal to 0, the next state is no change, Q of T. But T is equal to 1, the next state is the toggle. Okay, so clock is 1, that was like PGT the case. So T and Q over T, 0, 0, 0, 1, 1, 0, 1, 1. It depends on the T value, no change, 0. Q prime of T is like the complement, 0, 1, 1, 0, 0, 0, no change. Okay, so and then this is the two type and T and Q. So only 0, 1 and 1, 0. So that is for QT prime plus Q prime T. That was what? The XOR again. Okay, the two input of the XOR gate, the T and Q. So very be careful. Okay, very important. So that is for the deeply plot, the design with the deeply plot as well. All right, just practice, maybe all of them. All right, so now analysis of a clock sequence circuit we learned before the sequence circuit consists of the a little bit more complex sequence, the combination circuit, combine the logic diagrams with the memory elements. It depends on SR and then the flip-flops. Okay. All right. So in here, so now the analysis clock sequence circuit with a deep flip-flop. So we can just to this circuit behavior clock sequence circuit can be described algebraically by means of So this is the AX plus BX, and then this is the clock. What is it? PGT and 2D flip-flop. Okay, 2D flip-flop. So we can, the to express to the state equation. So from state equation, we can find the next states, a of t plus 1, b of t plus 1, and y from the equation. This equation we can derive from the circuit. Now, from here, we can also reduce to the present state, next state, x is equal to 0 and x equal to 1, and also we can find the y value. Okay, y value. For example, x is 0, y is 0, x is 1, y is equal to 0. But for this case, 0 to 0, 0, and 0 to and 0. Sometimes that was like reduced form. So after we're gonna make a second form or reduced form, we can draw the diagram. State diagram. The state represent by a circle, and then the clock trigger transitions between state are indicated by directed lines connecting the circle as shown in the figure. So the 002 00, 002 01, and 10, and 0120001. So, all right. So, d sub A is, this is the X, Y, A. So this is Y here. So d sub A. Okay. So symbol, we can make it, it's like characteristic the equation from the circuit diagram. Um, so this is the present state, input, next state. Okay, the input and present state is the next state. Okay, so from the next stage, definitely we can draw the state diagram in here. Right? Okay. Okay. So now um, from here, we wanted to analysis of the clock sequential circuits with a deeply plot. But in here, it's like the JK. So this circuit can be specified the JK flip-flop input equations. We can draw here the JA. Oh, I'm sorry. This is the B, the X prime. So B, the X prime. The A is what? B. So this is Y. And then the J is a B, the X prime right there. And KB is AX right there. Okay. Same thing. This is the XOR again. So maybe question one, you have to find the JK flip flop input the equations. And then so from here, you can find the next days if it was given 0000001 until the 111. So, well, we have a lot of the option. If you want to using for the J sub A, J sub B right there. But the next state issue, next state, you know, we learned before, 0, 0 what? No change. No change. 0, 1, reset, reset, set, set, the toggle and toggle. So it depends on the value. Is corresponding to the JK, 1, 2, 3, 4 is 4. So 1, 1, 1, 1. So you can find the Q over T plus 1. Okay. So yeah, so that is for the equation 4. Um, yeah, so we have the similar questions in the quiz, okay? So you can check in the quiz. I have also uploaded in the Blackboard and the link for the quiz 4. Okay. So, yep, as I said before, and then this is the let's say J, okay, right there. Okay, J A prime plus K prime A. So the J A, this is the J A, and this is J sub B, K sub B, and the K prime A. So just to put inside, and then we have to, for example, B, the A prime, and then KA prime means BX prime and N prime dot A, so that was B plus X prime A. So AB plus AX prime. So right there, A prime B. Here we go. Something like this. Okay, so we're gonna find A over T plus one and B over T plus one. Okay, so and then we're gonna find it. And then just like JAKA, we can extracting to from this the previous one for present state, input, and next state. For example, 0, 0. Okay, let's say 0 to 0. No, just give me a second. Um, so A is equal to 0, 0. Okay, and input X is equal to 0. Okay. So, oh, yes, we have already, we have the formula in here, right? So we have the formula here. So right there. And then from the previous one, so we can put inside, and then we can find it JA, KA, JB, and KB. Okay. So the after that, we're gonna draw here, 0 to 0, 0, 0 to 0, 1, 0, 0 to 0, 0, so. All right. So the next one is with a JK flip-flop. For this case, the same pattern. So you can practice, okay? Very important in the previous one, okay? And then some student has been mistake here. The state diagram, you can draw a state diagram like this one, okay? So the only X, you have 0 or 0, 1, so on. But the X and Y, you want to just like this one, okay? So you needed to X and Y, the transition. Between the transition, you have to make it. All right, so Millie and Moore state machine, you have to read the books and so on. Okay, state reduction. So some student has been confused for this one. That was, let's say, okay, but that was the given. From the given state table, we can draw, for example, the the present state and next state, the A to A, and 0 to 0. Okay. And then Y, because X is equal to output 0. And A to B, so A to B, the X is 1. X is 1 output what? 0. 1 to 0. Something like this. Okay. So you can try. So from the given state table, we can state reduction. What does that mean? So in here, so AF01 is same. So we can remove the last row, and then E is equal to G. That is next step. So where is the E? So that is like G. So that is after we're gonna, you know, replace E to G. GF01, GF01. So we're gonna just like next one. Here we go. So means F is equal to D. So D, D. Okay. So the finally, that was for the answer reduced state table. So we're gonna, a lot of time before. Okay, so state reduction. And then finally, stable reduction. Definitely you can draw maybe as well. All right, so state assignment. This is not the state reduction. Okay, so in the last session, we were learned before state reduction and state assignment. Uh, just like the state means sequential circuits, state present the current condition of the systems. The state will change depending on the input and determine the circuit next output or action. Why do you need a state assignment? Because the circuit cannot read and understand the letter ABC in the digital system. It's only recognize the binary value. Sure about. So binary value. So state assignment is the process of converting the symbolic state into binary code so that the circuit can recognize, store, and process them correctly. Okay. So key point, the way state assignment is that can be effective to efficiently large complexity and stability of the circuit. So we learned before the binary number, binary code for the each state, and then we can express for, from the previous state in the next state is like the A, B, C, D, E, S, so 000, 100, just binary code. Um, so they have the three different type. I strongly recommend you have to do the practice, especially get the gray code maybe which assignment. Okay. So I'm gonna just give you in here. I'm gonna give you the question, the gray code or the assignment three, the one hot spot, the one hot the code as well. Okay. So again, it depends on the state, the number. One hot code is like the 5 bits. So just only the one value is what you want to do. So 0001, 0010, 0010, just only number of one of the bits to make correspond to the each the state as well. Okay. So the please the read and the practice in here. So the one hot assignment, each state has only one bit set to one and all other bits are set to zero. Okay. One hot, the gray code, and then the binary code. Okay. So you practice. All right. Thank you so much. So we are done for in here. Okay. Oops.